we start with a triangle cut out of paper. This is the corner of the original 8.5 by 11 sheet of paper, so we're confident that it makes a good right angle. And we have copies of rulers, paper copies of rulers. Hopefully, I'm not sure that we're focusing well on that, but hopefully you can see that. This one is a copy of a ruler that's close to the same size as an actual meter stick. So we're measuring actual centimeters and millimeters here. This is a copy that's been reduced by a certain factor, so it still looks like it's measuring centimeters, but it's somewhat smaller. And we have a smaller copy and a nearly impossibly small copy. And we want to measure the lengths of the three sides of the triangle with each of these rulers. And then we're going to check our measurements for consistency. Excuse me, allergy season, can't do much about that. Okay, well, how do we verify the consistency? Well, the measurements ought to confirm the Pythagorean theorem. But of course, when we measure an actual object, there is no end to the precision with which it could be measured. And we can't measure it to complete precision. We can't measure it down to the last atom. We don't have anything accurate enough to do that. So there's going to be some uncertainty in the measurement. And of course, when we use a copy of a ruler, we're going to have to estimate tenths of a millimeter when that's possible to do, or maybe half of whatever the millimeter marking represents on this ruler. However, it shouldn't matter. Whatever ruler we use, the measurements should come close to verifying the Pythagorean theorem. To see how close, we take our three measurements and we then find the percent difference between a squared plus b squared and c squared. Now we understand, and I'm assuming we understand, the standard statement of the Pythagorean theorem, which I'm not going to teach people. You can look it up if you don't remember it. But if you've had at least Algebra 1 and geometry, you certainly know what I'm talking about here. So, how do we calculate a percent difference? Now, the class is just given this instruction and asked to do this. Now, one discussion we had was, what do we mean by percent difference between two numbers? And we need to learn to read statements, okay? I haven't given you this statement. You might not have ever seen a statement like this, but you know the English language presumably well enough to know that the word difference modifies the phrase between a squared plus b squared and c squared. I'm not sure that's even really a phrase, but whatever that is, it's being modified by the word difference. And then you have percent modifying difference between and so forth. So there are two words modifying this. The closest word is difference. So we would, if we didn't know anything else, at least calculate the difference between a squared plus b squared and c squared. And of course, once we have our measurements, we have to know that to calculate a squared plus b squared, in order to compare it with c squared, we're going to have to square a, square b, add them, and then square c, and make that comparison. So we find the difference between a squared plus b squared and c squared, and then we worry about this whole percent thing, which not everybody is going to be real comfortable with here. And this is because, of course, the idea of a percent difference is probably not something, it's not something that you would see on an SOL test. And if it's not on an SOL test, your teachers are not going to cover it because they have to cover what's on the test. That's a very bad situation, very bad for education, but there's a plus side to it as well. If the test was a little better, or a whole lot better, it would probably have the intended benefit. I'll stay off of that soapbox as much as I can bring myself to do. Okay, so we have to interpret the statement and then execute it. Now, I've done an example here. Okay, example, let's say that A was 6 B was 9, C was 11. Now those wouldn't be very good measurements because we would want to measure down to the millimeter, so we'd have maybe 6.35, estimating the tenth of a millimeter, and 9.47, something like that. But just to use easy numbers to illustrate what we mean by the percent difference here. A is 6, B is 9, C is 11. We calculate A squared plus B squared, which I believe, if I did my arithmetic correctly, comes out 127. It actually, that's wrong, so you can correct that, but we're just illustrating. Yeah, that's actually 117. Wrote that down carelessly. And you can modify the calculation, okay? So, it should have been 117, 121. I'll stick with the numbers I've got here. If it's 127 and 121, the difference would be the absolute value of 127 minus 121. What we're after here is the percent by which one of the numbers differs from the other. We don't care which number or which order the difference occurs. So we just do the absolute value here. The absolute value of the difference is 6. If we'd have used the right number, well, it would have been 4. But now, what's the percent difference? Okay, well, one student said, well, we're going to divide one by the other. Yeah, we're going to divide the difference by the ideal result. Now, we don't have an ideal result, so is A squared plus B squared the important quantity, or is C squared the important quantity? They're nearly equal, and instead of dividing the difference 6 by one of these numbers or the other, we divide it by the average of the two numbers, so that the average result, 127 plus 121 over 2, which is 124, is going to be our denominator. 6 is going to be our numerator. We're going to express 6 as a percent of 124. And that should make very good sense to you as a percent difference. Okay? Now, we can do a proportional difference. That's the difference, 6 divided by 124, and that comes out 0.484. And I did that calculation correctly in my head. Couldn't do 81 and 36 correctly. I got 127 where I should have got 117. But in any case, we have 6 over 124.0484. And as a percent, that's 4.84%. Now, you should understand that. That's what we mean here by the percent difference in this case. Now, there are more extensive rules for percent difference. When you use the 127 or the 117, it should be, or the 121 as your basis for calculating the percent. I'm not going to go into that terminology. I want to just talk about the intuitive idea of calculating this percent difference in this particular situation. Okay, we're not going to get into the detailed rules. You can read those rules. You can read the formulas. One point I make is that in the teaching of the class, often you get the formula and you never understand what the rule means or why it's important. Okay, and there's one other thing about the arithmetic, but I'm going to save that for a short video to follow this one.